Hello everyone, welcome to the Aerospace Lab, one of the best equipped and most advanced aerospace research facility in Singapore. Today we're joined by Associate Professor Teo Chiang Juay, who will bring us through the lab and show us the work that has been done. So Prof Teo, can you introduce yourself?
Sure. Okay, my name is Teo Chiang Juay. I'm the coordinator for the NUS Aeronautical Engineering specialization in the Department of Mechanical Engineering. So I look after this specialization. So this is a very popular specialization. Every year we have close to at least 40-50 students that actually enroll in our specialization. So in this specialization, we aim to teach our students all the different aspects of aeronautical engineering. So imagine you have an aircraft, right? The aircraft itself is a system. It consists of many subcomponents, like for example, the wings, the fuselage, the engines, the different parts of the aircraft itself. So we teach our students all the different subsystems and how they come together. Like for example, the structures. Nowadays, people always go for lightweight composite structures. Then, for example, here I show you some of the aircraft models that our students build, right? Some of the unmanned aerial vehicles. So the wings are the structures that create an upward force on the aircraft itself. So how do we go about designing the shape of these wings, right? So different types of wings itself will create different types of lift forces, and we require different wing shapes to achieve different sorts of missions, right? Then what provides the thrust force, the propulsion force to push the aircraft forward? It comes from the engines, right? So how do we actually size, right, the propeller blades? And then of course, for different types of applications like commercial aircraft, we have those jet engines. So we also have courses that teach students about the details of how a jet engine actually operates. We also have courses to teach the students how to design the different control surfaces, how do you control an aircraft. So we have a course on flight dynamics and controls. So we have the ailerons, the rudders and things like that. So that's the purpose of our specialization, is actually to incorporate all these different aspects, right, of aeronautical engineering and to give our students a holistic understanding of how an aircraft basically works, right?
So we've heard a lot about the UAV project so far, but one of the most exciting features of this lab is the wind tunnel equipment. So Prof Teo, can you tell us more about how the wind tunnel is used in the student projects?
Sure. So in some of our previous video clips, you might have seen our students designing wings of different shapes and sizes. So one of the important questions to ask is, for each wing profile that they get, how much lift force the wing actually experiences and how much air resistance, drag force that the wing actually experiences. So the wind tunnel, and we have several of these wind tunnels in the lab of different sizes to accommodate wings of different sizes and shapes. And the wind tunnel basically generates or creates a fixed wind environment, so we can actually regulate the velocity of the air. And for different air speeds, we can actually measure the forces acting on the wing, the lift force, the drag force, and that will allow students, right, to look at different types of wing profiles. Nowadays, we have 3D printing. We can always print out all the wings with different shapes and sizes and conduct experiments on them in the wind tunnel to quantify the amount of lift and drag forces that act on the wing, and therefore for the students to check on their design to see whether it meets their expectations. So a very simple example, like this is actually a model that we printed out using 3D printing. This is actually what we call a wing in ground effect craft. So it's actually a boat. It takes off from the surface of the water, but it has wings which allows it to generate, when it travels fast enough, there are lift forces, upward forces acting on the wings itself, so that's able to lift off from the surface of the water. So this was actually commercialized by a company in Singapore. So what happens is that we scale down the model and we were able to test a model of this wing in ground effect craft in one of our wind tunnels to quantify the amount of lift force and air resistance force acting on this prototype itself, and also to do refinements to the design, the shape of the wings, right, to enhance the lift force and reduce the aerodynamic drag, right? So we have a couple of these wind tunnels in the lab of different sizes. Some are in this lab, some are in other buildings, right, to support research as well as education in aeronautical engineering. We also have an engine test cell where we can actually test different types of combustion engines, right? Because a lot of these aircraft itself, they make use of jet engines. So we do a lot of research on combustion, detonation, propulsion in order to support those educational endeavors that are related to aeronautical engineering.
So earlier you mentioned that you work on UAV. So what kind of opportunities do students have and what kind of competitions do they take part in?
Okay, every year we have a team of students, perhaps up to 20 students, who work on unmanned aerial vehicles. And every year we send a team of students to participate in the Design, Build and Fly competition that's being organized by the American Institute of Aeronautics and Astronautics, or AIAA for short. So last year they went to...
Last year was Wichita.
Wichita and Kansas, right? So perhaps I'll let the students give a presentation of what they have been working on for this year's competition.
Okay, for this year's competition, we have to design, optimize, as well as manufacture and test two aircraft. Firstly, a bigger aircraft that is controlled using a normal transmitter, and the second one, which is a smaller aircraft attached to the bottom, which is dropped in mid-air. So what we have here is actually some of the components that we have already manufactured from the larger aircraft. So the first thing is this tail structure, which uses a carbon fiber boom for the tail, as well as white foam and reinforced with carbon fiber spars for strength. And then for here we actually have for the first time fiberglass wing. So past years they were actually created out of wood, but this year we chose to do it out of fiberglass. So this clear coat is a fiberglass, and then it actually has a blue foam core with another carbon fiber rod for structural reinforcement.
So in Aero NUS, we not only design the thing, we also design the mechanisms for the attachment point of like the X1, which is one of the small aircraft inside our missions.
Yeah.
And also a pylon. So we design inside SolidWorks, then printed it out and test to see if it works, and also optimize it such that it's best for our competitions. Apart from that, we also have electronics involved, like autonomous X1 aircraft. So we will need to code and also solder every flight controllers. So I'll say in participating in Aero NUS, we will learn engineering experience.
Thank you, Prof Teo, for the insightful tour. It is truly impressive to see how the students in the mechanical engineering program are able to work in a holistic environment, from design to prototyping to testing and implementation. If you are interested in joining the aeronautical specialization, do consider joining the NUS Mechanical Engineering program. Thank you for joining us.
Thank you.